Now student, after having the idea of percentage composition, we are going to discuss about the empirical formula. Students, basically we are going to discuss about the two, that is the empirical formula and the molecular formula. Okay, so from the earlier classes you know that the molecular formula is of water is H2O, or the molecular formula of carbon dioxide is CO2, or the molecular formula of ammonia is NH3. Okay, you have the concept of this. So students, a formula is basically a symbolic representation of one molecule of the substance, okay, which tells the number and kinds of atom of various elements present in the molecule. Now it is raised that how these formula are determined, okay, and the determination of the formula of a substance involve first the determination of its empirical formula. Okay, that's why it is necessary to study about the empirical formula. So whatever substance or whatever formula is given to a substance involves the first determination of its empirical formula, and after this the molecular formula was determined. So let us firstly discuss about the empirical formula, and then in our next lecture we will be discussing about the molecular formula. So let us begin. Students, as our topic is molecular formula, empirical formula, okay, so for empirical formula we firstly have to know its definition. So defining empirical formula, you have to just assume a condition that at this time you are not knowing the formula of the exact compound, whatever compound you are considering. Okay, so the empirical formula of a compound is the chemical formula, okay, which basically express the simplest whole number ratio. Okay, basically what empirical formula does is it express the simplest whole number ratio, okay, of the atoms of various elements present in one molecule of the compound. What I am saying you can better understood with the examples. So taking the very first example, okay, if somebody has said that this is benzene, okay, and how you can calculate its formula if you are not knowing, and I guess some of you are knowing what is benzene but many of you are not knowing. Okay, so for benzene, basically you just have an idea that benzene is having C6H6. Its molecular formula is C6H6. Okay, but here in your first year class the questions will be raised that you will given the percentage of the atoms or elements, and from that you have to calculate the formula of that compound. Okay, you are unaware of the compound, you have to calculate it. So for this, if the percentage composition will be given, so from there you will calculate the empirical formula, and from that you will calculate the molecular formula. How it will be do so we will see later, but firstly have an idea what is empirical formula. So now students, if talking about the empirical formula, so the empirical formula of benzene is CH. Don't it look contradictory? Earlier I have said that molecular formula of benzene is C6H6, and now I am saying the empirical formula is benzene is CH. So yes, you have to pay attention about these terms, that what are the terms asked. So when we are saying that empirical formula is for benzene is CH, it generally suggests that in the molecule of benzene one carbon atom is present for every one hydrogen atom. Okay, so if there will be one carbon atom, then there will be presence of one hydrogen atom for sure for each carbon atom. Okay, so from the mass percent data or from any data, if you are getting to know that the basic ratio of benzene is CH, that is one carbon and one hydrogen, one carbon to one hydrogen. So for this, if you have come to a conclusion that there is 6 carbon, then you can easily write that its formula will be C6H6, and this will be its molecular formula. Okay, now students, you can see the very second example. Here you can see the empirical formula of hydrogen peroxide. Write down N here, it is missing. Hydrogen peroxide is HO. Okay, so empirical formula of hydrogen peroxide is HO. What this suggests that one atom of hydrogen is present for every one oxygen atom. Okay, so if you have calculated that in hydrogen peroxide there is O2, okay, 2 atom of oxygen, so you can easily conclude that the percentage, the atom of hydrogen will be also 2. Okay, so this is what the molecular formula of hydrogen peroxide. Okay, won't it very easier? So basically, after seeing this, you can also define it in another way, or you can basically say that the empirical formula of a compound basically represent the atomic ratio. Okay, it is representing the ratio that for every single C there is one H, or for every one H there is one C. Basically we are talking about the atomic ratio. So this is what the empirical formula. In our next lecture we will be discussing about molecular formula, and after that we will solve some numerical question on this concept. Okay, thank you class.